Okay, in this lesson, we are going to be looking at hyperbolas that have been translated left, right, up, down, whatever direction, but they are not going to be centered at 0, 0 today, okay? Here are sort of the basic formulas that you can use. Again, the center is going to be h and k, like it has with all of the conic sections we've looked at. Just a reminder that you can tell something is a hyperbola if both the x and the y quantities are squared, and also that it has a subtraction sign in the middle of the formula instead of an addition sign, because if it was an addition sign, it would be an ellipse. You can kind of look at all of these um, pictures, and there's a whole mess of formulas on there that probably don't make a whole lot of sense until we sort of dive into this and kind of think about how it looks, okay? So that's what we're going to do. First of all, this first problem asks us to find the standard form of the equation of a hyperbola whose conjugate axis, that means the one that does not connect the foci. Okay, so it's the axis that does not connect the foci. So whose conjugate axis has endpoints at -1, 4, and at 5, 4. So I'm going to go ahead and plot those, -1, 4, and 5, 4. All right, so that's my conjugate axis. Again, it does not connect the foci. The transverse axis, so that's the one that does connect the foci, has length 8. So that means the entire axis has length 8. And by the way, my center then, my center would be right here at 2, 4. Okay, so I'm going to just write that down right here. I'm going to color code this, try to a little bit. So my center is at 2, 4. So what that means already I know is that h is 2 and k is 4. Okay. Then again, it says my transverse axis, so that's the one that connects the foci, has a length of 8. So the entire axis has a length of 8. Half of it then would have a length of 4. So I'm going to go up 4 and down 4. Okay. And what I need to do is I need to think about how this will look. Okay, so I'm going to sort of make a box that highlights this. So my box is going to go like this. I'm trying to draw straight lines, but it's not working so well. My box will look something like that. Okay, then I am going to go ahead and I am going to make a line that connects the corners of those boxes. Okay, so if I make a line that connects the corners of those boxes, it would go something like this. By the way, these are called asymptotes. Okay. So that has an asymptote. You can kind of tell what the slope of the asymptote is right now, if you think about it. The slope of the asymptote is rise over run, right? So I know that in this case, I can see this already. My rise is 4 and my run is 3. So the right-hand side of that asymptote, the one that goes from bottom, this one right here, okay? This asymptote has a slope of 4/3 because it goes, my rise is 4 and my run is 3, just so you know. Okay. What I need to figure out is I need to figure out where my foci are going to be. Okay. And I can do that pretty easily. I know that my foci are along my y-axis because the blue dots that I drew originally were along the conjugate axis, which means that's not where my foci are. Okay. So what I do know is that my foci are going to be up here and down here somewhere. And I know that my hyperbola is going to hug those branches and go something like this. Okay. So I know that this right here is a vertex, and it has a vertex of 2, let's see, 8. Okay. So this quadrant or coordinate right there is a vertex, and it's 2, 8. This coordinate right there is also a vertex at 2, 0. Okay, just so that you can kind of have some information in there. All right. And what I need to do is I need to find the distance of my foci. Okay, so we already know that A is along the axis that connects the foci. So A is along the y-axis, or parallel to the y-axis. So my A is my up-down value here. In this case, A is 4. Okay, your B is along your conjugate axis, always. So my B is 3. And then here's what's kind of tricky. This is C, and I want you to remember that this is also C. Those are the same distance. So when you figure C out on the triangle, you also figure out how far your foci are away from your center. Okay? So I am going to erase that for right now so that we can figure out what C is. Okay? So what I know is that A squared plus B squared equals C squared if I'm looking at that right triangle there in my box. Okay? A squared plus B squared equals C squared. So I have 16 plus 9 equals C squared. Wow, this came out to be pretty. Aren't we lucky? So C squared is 25 and C is 5. Okay? That means that my foci are 5 up from my center and 5 down from my center. And I actually estimated those pretty good. Okay? So my foci, this point right here, will be 5 up from my center. So here's my center. And if I go 1, 2, 3, 4, 5 up, my foci right here is at 2, where was I at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 9. And my other foci will be down here at 2, -1. Okay, this is kind of becoming a mess. I wish I had more colors. Okay, our job though in this problem was to figure out the formula for this. All right, so to figure out the formula for this, then I am going to use the formula where I list the y first because my transverse axis, or the one that connects my foci, is my up-down axis or my y-axis in this case. So my formula is going to go like this. Y minus k squared over a squared minus x minus h squared over b squared has to be 1. Okay, I already know what h and k are. I already know what a and b are. So I'm just going to plug in everything I know, and I will go from there. Okay, so this becomes y minus k, which we know is 4, over a squared. A is 4, so a squared is 16, minus x minus h, which we know is 2 squared over 9, because that's b squared equals 1. Okay, so that should be that problem. All right, one more. This time, I am giving you the formula, and I want you to find some different things about it, okay? So some things are easy to identify. You do not have to graph these at all, but I think it is easier to graph them to be able to picture what's kind of happening, okay? So I can see that this formula has an x and a y squared. It has a minus in between, so I know it's a hyperbola. I can see that the x is the one that's listed first, so that means I know that my transverse axis, or the one that has my foci on it, is my x-axis or my left-right axis on this hyperbola. Okay, that's what I know. The formula that it gives you is x minus h squared over a squared minus y minus k squared over b squared equals 1. So if you kind of think about what's plugged in there, right here, your h value will actually be -1. Your k value has nothing behind here, so it's a 0. Okay, so I'm going to write this. H is -1. Your k value is 0. Okay, I also know that this is a squared. So a squared is 4, which makes a be 2. this is b squared. So b squared is 9, which makes b3. Okay, so I have all of that information. And with that, I have to find some things and use them. Okay, so here's what I'm going to start out with. I will start out with the fact that my center is HK, which in this case is -1, 0. Okay, so I'm going to plot my point on that graph. My center is -1, 0. All right, my vertices, you can see if you use your handy dandy little formula, your vertices on this kind of hyperbola go like this. It's h plus or minus a and then k. Okay, so your vertices are h plus or minus a and then k, right? H plus or minus a, k. All right. So one vertice would be -1 plus 2 and then 0. So -1 plus 2 is 1. And then your other vertice, h minus a, would be -1 minus 2, which is -3. And then k, which is 0. Okay, so we got that far. And now we need to be able to find our foci, which is a little bit trickier. Okay, so your foci are h plus or minus c, and then k. All right, so here we go. To find your foci, it kind of helps to draw it, or you can use this little Pythagorean relationship in here, and you can pretty easily figure out what c is without having to graph this if you want. Okay, so here we go. C squared we know is a squared plus b squared. Okay, so in this case, c squared will be 4 plus 9. So c squared will be 13. So c is the square root of 13. So if we don't want to have to draw this, we really and truly don't have to. Okay, this is what this is going to look like, the foci. So the h value, remember, was -1. And my c value is root 13. So one of them will be -1 plus root 13. And then my k value, which is 0. And the other one will be -1 minus root 13 and my k value of 0. Okay? If you want to go ahead and graph this, this is what you're going to do. Your a value is 2, which means I am going to move 2 to the left of this dot, 2 to the right of this dot. Okay, to the right of the center. My b value is 3, so I'm going to go 3 above the center, 3 below the center. And I am going to make my box. Okay, I'm just going to practice this. I'll make my box that kind of connects those. Like that. I'm going to make my imaginary lines in here. Let's see. It's a little thicker than I wanted it to be, but that's okay. These are my asymptotes. But you have formulas for the asymptotes if you want to use them. You certainly can. I know that this is a hyperbola that has to open left or right, because left and right, I should say, because the x value is listed first. So I know that this is going to be my hyperbola. Okay, something like that. I know that if I want to graph my foci, the square root of 13 is 3.87. So I am going to go 3.87 to the right of the center, so almost 4 to the right of the center, like right about there, and almost 4 to the left of the center. Right about there are my foci. Okay, so if you want to graph that, you certainly can, and go from there. Okay, so I think that will do that. Just so you know, you do have that eccentricity formula also. I don't know that you're going to need to use it for hyperbolas, but it does also talk about how kind of skinny and how fat the hyperbola branches are, is what eccentricity means in hyperbolas. So just so you know that, okay? So I think that that will do that.